Hey, how are you guys doing? Alright, so we are getting pretty close on getting this graph plan search working in C Sharp, which is great. But what we have to do next um, is get mutexes working, because I realized, hey, if you don't know what two steps are mutex, you can officially get the answer to the cake problem in one step. And that's basically to not eat your cake and eat your cake at the same time, which you can't do. so, so that's where mutexes come into play. So we're gonna have to do this first. Extend playing graph until all goals are non-mutex. So no problem. We already have that implemented. We just gotta do it. So let's open a project here. I'm working on the planning project here. Yeah. So I'm going to stay out of Unity just for now in the beginning, and then we will work our way forward. Okay. So the plan graph. I should really have a mutex plan graph. So let's go to plan. Let's go to where we're initializing this. So here, when we make the plan graph, we should say true here. All right. So far, that should calculate the mutexes if I had everything implemented correctly there. So let's hit play. Let's see if we can get to that next stage. Okay, and you should be, what, 2? 3. You should be 3. Awesome, so you do go all the way to 3, which is great. Alright, so now the next hard part for our graph plan. So that's the same, that's the same, that's the same. Basically, every pair of steps in S must be non-mutex. So that's what we have to check right here, is that we have to do a check for this before we add it to our steps. So I think I know where to do that. So we're going to go into graph plan. When we're returning the step finally, which is here, yeah. So before we add the step, we have to check for every pair if all steps non-mutex, and then you can just go ahead and pass in the steps. Then add it. And I think that's all we have to do. Then we just got to implement this function. So I'm going to try to do this right now. And I'm going to move it to the end just because it was one of the later ones done. Alright, so this is what I'm going to do. For each plane graph step in steps, and then for each other step, if step does not equal other step, plane graph dot is mutex. How do I check is mutex? Oh, do I have to get the level? That's a good question. Wish I could just do it from the plane graph, right? Or maybe I can't. This is not plane graph. Plane graph. We get plane graph, extend, get level, get root, get plane graph stat, get plane graph literal, get max level. I think that's what I gotta do. Alright, that's what we gotta do. Unfortunately. That's fine though. Plane graph get max level. That should be a thing, right? It's private. I'm gonna add is mutex at level. As I feel like that is an important is mutex at level. And I'm just gonna do it for the steps now. Okay, yeah, that's fine. Yep, is mutex at level. Get the level. If plane graph level exists, PG level exists. But now we're not going to do that. Is mutex. Here we go. We forgot to do one crucial thing. Plane graph is if plane graph level is plane graph level mutex, then you're going to return this as plane graph level mutex. Plane graph step other step int level. Alright, so we got return plane graph level as plane graph mutex dot is mutex, and then we just say step other step, and that should be pretty good. Otherwise return false. Okay, I like that. It's a good function. And honestly, why do I keep saying honestly? Well, I'm gonna make that a capital I, just because we are dealing with C#, and I like to keep it all C# syntax. Graph plan. Plane graph dot is mutex at level. Step other step. It'd be nice to have a level, so let's see if we can pass that in too. We're going to return false. And if everything passes, we're just going to return true. Let's see if we can pass that level in. I think we have to get the level, right? Get all steps, keys, V, set of steps. Let's go. Let's just pass in level. Where are we doing this nonsense? There should be like some crazy big. Yeah, you. And then we pass this guy into here. Alright, so now I think we're doing it. Alright. Let's test it. We'll see. Alright, we're jumping into this function. Find plan. We're going to get all the goals. Our goals right now is have cake and eat cake. Awesome. Is the plane graph leveled off? Well, first of all, what is the plane graph? The plane graph is 3 levels. Awesome. That's exactly what we want. We would have found that out in just a second. 3. Find the plan. Okay. So we're at level index 2, which it starts at a 0 index. So we're not at 0. Set of steps. I'm going to assume this works. Let's see. Okay. Oh, and it knows it's... I should have looked at it, but it looks like it worked. Basically, I wanted to see all the set of steps to evaluate it, but I see that it just kind of worked. So I'm not going to argue too much. So alright, we're going to grab this first set of steps, get the literals, which is basically now going to be, can we not have cake and eaten cake? And then we're going to jump in here. How do you jump in here? F11. Alright, so it says 0. Alright, how do you get that? So set of steps says, hey, you can only do one action to do that. And it's basically eat cake, eat cake. Yeah, I know. It's duplicated. And I'm going to jump in here. Yep, our new goal now is going to just be this one. Have cake. I'm going to jump in here. Levels equal to 0, so let's see if this exists at the goal. So goal is have cake. Literal is going to be have cake. And then we're just going to see if this exists at level 0. Doesn't equal null. Is 0 greater than -1? It is. Is it less than or equal to level? It is. So it's going to return true. So that's going to return true. That's going to return true. That's going to return true, which is not true, false. So we'll skip that. There's no more goals. You're going to return true. 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 And you're going to return true. And then bam, plan done. All right. Hi. Hi. Cool. So what would be better is a list of steps. So I might do that. This could be a little different. We'll just call the list of steps a plan. And we're gonna have to bring this all the way forward. Alright, so find plan is going to be a list of steps. But everything else should be fine. Okay, yeah, I think everything else is cool. Alright, so list of step is going to be, actually let's go ahead and just do this. List of steps is going to be plan, awesome, and then basically we're just going to say, hey, plan equals find plan if plan equals does not equal null, return plan. And then if you make it down here, we're just going to have to return null. Okay, not too shabby, Abby. So this find plan's okay. Okay, we're gonna have to modify this just a bit. If contains goal, return new list of steps. Else return null. Okay, that seems good to me there. I just need this part. So list of steps. And I'm just going to say you are a plan. Alright, so if plan does not equal null, return, can I say plan.add? Alright, we're going to do two things. Plan.add steps, add range steps. Alright. For each plan graph step in steps, plan.add plan graph something, plan graph step dot get step. Return plan. Nice. Otherwise return null. Ooh, let's see. Benchmark. Scared and excited all at the same time. I'm gonna just wait. What did I do? Let's hit F10. Let's see what happens. Alright, here's my plan. Eat cake, bake cake. No op. Okay. You're gonna eat your cake, you're gonna bake your cake, and then you're gonna also not eat your cake. Oh, okay. I guess you really don't add your persistence plan. Yeah, okay, good call, good call. So on graph plan, here, no, when I'm adding the steps to the thing, this one. If step that is persistent. So definitely don't add the persistent steps. Okay. Let's go back. The other thing I need to fix is the whole duplication thing. Nice. So we only got eat cake and bake cake. What else do we need to do? So it works its way back, makes a plan forward. Done. So Mutex is good, like it worked, and we're getting plans, which is amazing. Now we just gotta start doing some other stuff. What do we have to do? The double... I know where to handle it. This part. Can we... I gotta see why it's happening first. Alright, so we know the problem is pretty much in getting all the sets of steps, right? So let's see what we can do to alleviate that. Okay, so this set of steps, we have no set of steps yet. Alright, so we're gonna make a new set of steps. So far we've added a step, bake cake. Alright, so we're at level 2. Let me see if I can pull up the graph right quick, just so I can see what's going on. Actually, give me the best. So yeah, I'm like here. So it's getting bake cake. Alright, cool. So bake cake is definitely one of them, and no op not eating cake. That's our... So you're going to jump back in. Our first step we're going to check is eat cake. Okay, we're going to do bake cake and eat cake. Yep. And then basically that is past our threshold. Are the steps non-mutex? They are mutex. So we're going to have to return set of steps. So we haven't added anything to our set of steps. Okay. So now we're going to remove eat cake. So we're back down to bake cake. So now we're going to do no op eaten cake. Okay, good. Which is gonna do great here, I think. So now our two steps we're looking at is bake and don't not eaten cake. I mean, you've already eaten cake. Awesome. Let's add that. So we got one set of steps. So this is good. So no baking. We can always do the no op have cake. So that's the second step, but what we'll find out soon is that any other combination of that is going to be mutex. So we're going to say, hey, no op and eat cake. They're going to be mutex. So we're going to remove that one. And what's the other one we can do? Eat cake, I guess? Oh, now it's the no op cake. Okay, yeah, yeah. But no op eat cake and no op have cake are also no good. So we're going to remove that. And yeah, that is all we got here. So we're going to remove that step. There's no more steps there. Alright, cool. And since we got the set of steps, which is just this one, we can now make it a result. The result is 1, and it has an array of 1, right? Of 2. Oh, cool. Then we can return that result. And there we go. We got that set of steps. Then does its thing. But now we're going to be at level 1. And this is where I think I'm getting duplicates, which is what I should have just started out with. Alright, so we have steps. For each set of steps, which is what? Steps with effect. Okay. So we're going to add step eat cake. We're adding eat cake with eat cake. That's what I'm trying to wrap my head around. I can't do it. I don't know. Oh, okay. Basically, I think I see. The child of not have cake is eat cake, and the child of eating cake is eat cake. So now that we got both of those, It's gonna be tougher than I thought. I think I want to say okay, well, I guess if there's any duplicates, you're doing the same action twice, and they have the same effects, right? So, I think I just remove dupes. Alright, that's fine. So I'm going to just put something here. New steps equals remove duplicates of step. This should also be a list of playing graph steps, I think. Alright, so let's make this function. Okay, sorry. I meant to do that. Okay, we're gonna make a new list of playing graph step. New steps equals new list playing graph steps of steps. Alright, so that's basically a clone. So we got a clone of that steps. And now just to kind of iterate through it, I'm going to do the old-fashioned I equals new steps dot count minus 1 I greater than or equal to 0 yep, sorry, I minus minus, and just go down here for j equals new step counts minus 1, j greater than or equal to 0, j minus minus, if new steps I dot equals, oh gosh, there's dot 2 equals, I don't like that at all, dot equals new steps j. Don't forget to say if I not equal to j. That's an important one. New steps. We're gonna remove it from I, right? Remove at I. And break, right? Break. I hope that works. Let's see what happens when we get here. Alright, so our steps, let's see, steps has no dupes, so if I go through this, steps is still the same. Cool. And just add that. Nice. Alright, let's keep going. Steps. Okay, this is where I feel like it should just delete it, so I'm going to jump in. New steps is basically to be the same thing. I, J. Yep. So basically we have Eat cake, eat cake. They do equal. Break out of that loop. Or base, no, you know what? I think we do it from J, right? And don't break. Yeah, break. Because we're only going down by 1. Yes, this is right. But we gotta break. Cool. Alright, I feel better. Let's go take a quick look, and if this all works, I'm gonna call it here. So let's start this. I'm just gonna hit F10 and hope for the best. Oh. Shoot, let's just stop it and do it again. Alright, a plan forms. We have to eat cake and then bake cake. Woohoo! I feel pretty good about that. Because all we have to do is eat cake and then bake cake. And we don't actually do the non-persistent steps. Like it. I like it a lot. Alright, we got a graph plan working, I think. I wish there was a better way I could test this. Alright, nice. So I got it all. It's working. We got graph plan working. Now we just have to visualize that somehow. So that is going to be my next project, and I'm not sure if we're going to work on that today or sometime later this week. But we got graph plan working. Gosh, it'd be nice to test another what you call it? Test another domain. I mean, I probably could right quick. Let's see. If where are we? Benchmark. Does benchmark have the problems? You only have the cake. That's okay. I won't test it here, but I'll test it later. So I'm gonna go ahead and call it. Oops, forgot to open source tree before the stream, so it's gonna freeze up a little bit. See, it's already freezing. I can see that my mouth is not moving, but I'm talking. Okay, what's next before I wrap this up? Let me get everything I need to do done. Perfect. Mutexes. Implemented mutexes. And now graph plan comes up with a plan. Nice. So this was episode 23. Awesome. All we messed with was those 3 things. I'm gonna go ahead and commit that. Alright. With that being said, I am done. Thanks everybody. I'll catch you guys next time.